Uh, Thank you everyone for coming along. Today I'm here to talk to you about the state of Python on Android. My name's Chris. You can contact me through any of the details on this front slide. Tweet frequently. I won't respond during the talk, but you can find me on that username. Hi. Thank you to PyCon Canada for inviting me to come along and give this talk. It's really an honor to be invited here and a privilege to be able to speak to all of you. So, we're here at PyCon. I imagine everybody who is here considers themselves to be part of the Python community. And we all love Python enough to give up a weekend to attend a conference about Python. But a question that I myself have wondered for quite some time is why people actually use Python. And to figure this out, I conducted an exceedingly scientific survey. I asked everyone I know on Twitter why they use Python. And I got quite a few responses. Some people, they like the range of libraries that are available. Some people are fans of the syntax. Some people like having access to documentation. People value the community. People value being productive in Python, and some people value the simplicity of the language. So I think we all agree, Python, it's fantastic. We like Python, don't we? Great. Yay. Oh, applause. That was unexpected. So with these credentials, Python really should be the language that everyone uses because it works everywhere, it's great. And indeed, Python is widely used in a lot of applications. But over the last few years, this thing called mobile has appeared, basically out of nowhere. And we as a Python community should be concerned about it. And the fact is that we aren't. Python developers aren't really considering mobile as a worthwhile avenue to develop in. And even more concerning for us as a community is that people who want to develop apps for mobile devices aren't considering Python as a legitimate language to do their development in. And this is a problem. So in today's talk, I sort of want to look at why this is the case. And I'm going to look at three different things. I'm going to start by looking at the field of mobile computing as it currently stands, specifically at Android, because that's what I know. I'm going to talk about why people care about Android and what makes it different from the other mobile platforms that are out there. Then I'm going to look at what constitutes an app in the world of mobile computing. And then I'm going to survey the landscape of Python on Android. And I hope to answer these questions. Firstly, why aren't people using Python to make apps at the moment? How much can we actually do with Python on Android? And how can we improve the situation that I've just described? Before I begin, I'm Australian. Apologies if I use any strange words. If you do have any difficulties understanding me, I offer translation services at the end of the talk for a small fee. I'm a Python native. I've been coding Python on and off since about 2004. And I co-chaired PyCon Australia, which finished up last month in my home city of Hobart. Alas, as much as I like Python, I've found myself doing Android development professionally for the last 3 years. And that has coincided with me not coding any Python professionally for the last 3 years. And this makes me really, really sad. So this talk is as much a talk about why I don't use Python in my day job and justifying that as it is trying to convince you to start coding Python on mobile stuff. So to begin, let's set the stage. What is Android? Why is it important? And why should we as Python developers care about making apps for Android? So to do that, we first need to look at the field of mobile computing. This is the first mobile phone I owned. It had like 4 lines of black and white text. It was very heavy and had this funny external antenna at the top that made it not quite fit in your pocket. And it wasn't terribly remarkable in terms of features. It could make calls, it could send text messages, but it had the first thing that I could recognize legitimately as an app. It had the snake game. Right. Simple game, you didn't need to learn anything to figure out how to play it. You could just pick it up when you're on the bus, put it down when you need to get off and walk somewhere. It didn't demand much of your attention. Now, a few years after this Nokia phone came out, smartphones started appearing. And I don't think these phones had anything that resembled resembles what we consider mobile apps today. Instead, they had apps that resemble cut-down versions of desktop software. So you would have a large keyboard so you could bash out Word documents. You would interact with a stylus because you wanted to change your spreadsheet. This is not something that a general consumer would want. It's great if you had business uses, but I would not want to have bought one of these. The first mobile device that actually resembles what we use today is this one. Except it doesn't quite resemble what we use today, because when the iPhone first came out, there weren't actually any apps available for it, or you couldn't develop third-party apps. That didn't happen for another year. So when we talk about developing apps for mobile platforms, we're talking about a field that is just over 5 years old only. Android came out in the same year. So when we talk about Android, we're talking about a platform that is basically the same age as iOS is for app development. Both of these systems have influenced each other's development and design decisions. And so a lot of the things I talk about in Android also apply to iOS. So what is Android exactly? Well, at its most simple, it is an operating system. It is an operating system that you run on phones. It can also be an operating system that you run on tablets or on your sunglasses. Android is really, really widely deployed. In the first 3 months of this year, 156 million Android smartphones were sold. That compares with 40 million iPhones. And to put that number into perspective, Android smartphones alone in the first quarter of this year outsold full-size computers by a factor of 2 to 1. And sales of traditional computers are slowing at an unprecedented rate. So not caring about Android is not caring about the single biggest selling consumer operating system out there at the moment. So mobiles are smaller than full-size computers, right? So as well as having a different form factor, there's a key difference between mobiles and full-size computers. And that is that people use mobile devices when they are mobile. And the things that people want to accomplish when they are mobile are mostly task-oriented. People want to solve tasks that are immediately important to them. So good mobile apps make it quick and easy to solve tasks and then get out of your way. So this means that you need to have a low cognitive load. You use them when you're interacting with the real world. You might be walking across the street. You might be walking in front of a bus. You want to make sure that you do not cause traffic accidents just because you're using your mobile device. The screens on mobile devices are small, and whilst you might be used to mice, the pointers that you have on mobile devices are ultra-low precision, quite big, and have a habit of getting in the way of your screen. So you need to optimize your UI for having 3/4 of your screen occluded at any given time. This means that you need to have things in similar places. You need to have a consistent language of design. So even though these are two completely different apps, you can see bits of the control appearing in the same part of the screen on them. Having consistency means that your app is easier to learn, and not being consistent means that it's more difficult for your user to context switch between multiple apps. And indeed, the consistency of design that is enforced by mobile platforms these days means that when you have like developer documentation, you see design as well as development being given equal prominence. And this is not something you tend to see in other fields of development, even the web. Especially on Android, big apps with lots of features are frowned upon. The best Android apps are small. They solve a single task. They get launched from within other apps. When an app knows that another app that is on the system can solve a problem, they launch those apps. So as an example, Android has an image management system. So on the left, you have the camera. That is used for image capture. Then you have another app, the gallery, which is used for managing and organizing your images. And then the system provides an API for sharing images. The gallery doesn't need to know precisely what apps can receive images. Just apps say, hey, I can receive an image. This is using a native API not just to make things easier to code, but easier for your user to learn. And I think the final and probably most important hallmark of mobile devices is that software distribution is curated. So this is things like the App Store and the Play Store on Android. And this means that the emphasis of software creation on Android is on the native app. And what should concern Python developers and the community is that the web is very much a secondary experience on mobile devices. To give you an idea of how this is communicated, here's a marketing photo from, of the Nexus 7. And down the bottom here, we have some apps. So let's take a look at them. The first one here that I'm going to point out is Chrome. It's a web browser, so you can do the web on a mobile device. But then every other app that they promote here is for a replacement for something that already has a decent mobile web experience. People are trying to get you off the web, which is why you have this last one, the store that lets you get at more software for your apps, or for your phone. So people expect to find software through these curated channels. They don't go searching for things on the web. And even then, another important pattern is that apps, if they think that they can provide a better experience than a website, they'll offer to take you to that native app. So for example, you ask for a geolocation, you get Google Maps open. You ask for a YouTube video, the YouTube native app provides itself as an option to open. This should be concerning to you because it means that, that native apps are preferred over web. So, people want to use mobile devices because they are mobile. And most of the tasks that people want to solve involve being connected to a network. So mobile networks come with their own set of problems. They're inherently unreliable. People store themselves in Faraday cages on with great regularity. People use public transport. They put themselves through black spots like tunnels and crowded places like the city centre. People use inherently unreliable and bad networks. So your app should do its best to not break if it drops a few network packets. And you need to make sure that your app works to some extent, even if you can't get on a network at all. So we have these three things that, that I've just described: having a low-effort UI, playing with a native ecosystem, and being resilient to a network. And in concert, I refer to this as UX. It's not just a UI thing. And so to quickly finish off this section of the talk, let's quickly look at how you write code for Android in the official way. And I get to start off with some fantastic news, and that is that the language for writing Android apps is Java. Isn't that fantastic? I'm glad you think so. So let's see how developing Java on Android differs from writing Python. So you write Python code, you basically write the code, and then you execute it on CPython or PyPy or whatever. As far as you, the user, are concerned, there is no separate compilation phase. And as an aside, it's worth considering that the machine on which you develop Python is often the same machine as you run your code on, but it might not be the same. In cases where they're not the same machine, I'm going to say the machine that you develop on is your development environment, and the machine on which you run it is called the target device. This is important because people do not tend to write mobile apps on their phones. So if you've coded Java before, you'll know that there is a second step in the middle. You have to compile your code to JVM bytecode before it will run on the Java VM. And in general, the compilation phase needs to happen before you execute it, and you can't compile on your target device in general, or you don't. Now, Android does things slightly differently. It doesn't use the JVM. It has its own low-level virtual machine called Dalvik. And Dalvik doesn't use Java bytecode, it uses its own bytecode format. So it does use the Java toolchain, however. So you produce your Java executable as you normally would, but that won't run on Dalvik. Instead, you need to run a separate conversion phase. So you take your JVM bytecode, you convert it to Dalvik executable, and then you can run it on an Android VM. So this basically means that you as a developer see the Java toolchain. Once you have your code ready to deploy, it gets converted sort of transparently. And importantly, the conversion phase has to happen in the development environment and not on the target. So this basically means that you have something that looks like Java to a developer, but for which everything that we know about Java infrastructure is completely wrong. Isn't that fantastic? So, you now know a tiny bit about the landscape of Android. or mobile, and where Android fits into it. And you now know that I spend my day writing Java code. However, this is not JVM code, it is code that's targeting the Dalvik virtual machine. So, knowing what Android is and why people care, and how you're meant to code for it, let's look at the defining features of mobile apps and how you go and code them. Now, I'm going to say that there are 3 ways that you can go about writing an app that runs on Android in some way. So the first, and possibly the most accessible to people who code Python, is the mobile web. The second is to make apps that deploy onto Android, but aren't written with Android in mind. I'm going to call these semi-native apps. And the last is to write apps that are developed with Android in mind in its entirety. So the least native way to write mobile apps is to write mobile web apps. And mobile web apps should be reasonably familiar to you because it is basically the web, but mobile. And indeed, if you have a well-written mobile web app, or if you have a well-written web app, the only real difference that you need to deal with is just to change the user interface, make sure that the buttons are big enough to touch, there's no clutter so that your entire interface fits on your screen and such. Potentially easy, maybe. HTML5 has a whole bunch of features that make this possible and reasonably easy. It has things like geolocation, so your mobile web app can know where the phone it is on is. You can store stuff offline. You can have client-side storage. They're all things that make mobile apps useful. And indeed, HTML5 was so good back in 2007 that Apple thought that this should be the way that all mobile apps would be created. Steve Jobs said, "You will be surprised and pleased at how fantastic mobile web apps are." He didn't agree for very long. 9 months later, iPhone 2.0, now with an SDK. Isn't it fantastic how we have all these native APIs that you can use to get unique things on iPhone? So let's take a look at why people don't really settle for mobile web apps. Firstly is that, like I said earlier, mobile platforms are characterized by having consistent design. With the mobile web, you basically pick your own design and go with it. So if you want to make something look like a particular mobile OS, you have to go and make something look like a particular mobile OS. And indeed, the PyCon Canada mobile web app does this. It's designed a fantastic HTML5 app that fits in perfectly with the iOS human interface guidelines. But it looks completely out of place on an Android device because they've gone to all the effort of making it look like iOS. The second problem with the mobile web is that people expect to be able to get apps through their curated software distribution channels like the App Store or the Play Store. So you go to the PyCon Canada website and here are your instructions for installing the app. Indeed, you can't find the PyCon Canada app on the Play Store. So to find it, you have to know that there is a mobile web app out there. You have to know the URL for the mobile web app. If you didn't hear it in housekeeping, then you probably don't know it's there. This distribution mechanism completely limits your exposure, and it's not what your users expect. Finally, mobile devices are subject to different network conditions. So if you've accessed a website on a laptop, you're almost certainly going to have network access for as long as you're using that site. Fixed networks are quite reliable. If you're on a mobile device, you hit a site once, there's no guarantee that the network will be fast or remain fast, if the network will even stay up for long enough to finish a request, or even if the network itself will remain the same. You might switch to Wi-Fi halfway through loading a page. This is important because on the web, the availability of the network defines the structure of your app. You click a link, that's a new HTTP request. If you pull down an entirely new page with every link, and that page pulls down all of its UI on every load, then your site is really going to suck for mobile users. So making a web app that works on mobile is basically as much about making sure that your app works offline as it is about making it look nice and behave nicely on small screens. In terms of running offline, the PyCon Canada app is actually really good at that, so good job there. So Python on the mobile web, I guess it's a solved problem because you all tolerate writing JavaScript code for your browsers. If you're producing a web app with a Django backend, then you really don't have to do anything extra on the backend to make it work in a mobile context. It's all front-end stuff. So the next type of app I want to look at is what I'm going to call semi-native apps. And these are basically apps that you can find on the Play Store or the App Store on the iPhone, but they're written for a cross-platform toolkit, and so aren't written with Android specifically in mind. There's a couple of popular frameworks in this case for doing HTML5 and JavaScript apps that are cross-platform-ish, such as PhoneGap by Adobe, Titanium by Accelerator. They're just both ways of packaging offline HTML5 and JavaScript apps. And this solves the problem of a front-end web app dropping off the network because most of the UI is already on the device. Indeed, this is actually a good way of packaging up a nicely defined web browser to wrap a mobile website so you can put something on the Play Store if you do have a mobile web app. PhoneGap is really good for that. This is a screenshot from the same app written in Titanium. They do a semi-okay version of smoothing over major UI differences, like they've put on the Android version, the tab bar is at the bottom on iOS. Oh, sorry, it's at the top on iOS, it's at the bottom, and the buttons have been swapped around. But by and large, the UI still very much looks the same on both platforms, and indeed, the Android version looks a lot like an iOS app still. So you get apps that are sort of good on both platforms, but not great on either. If you don't go down the HTML5 route, the alternative is to use something that provides entirely native widgets and style. This is a screenshot from an app that is running on Android, but it definitely does not look or feel like an Android app. Like there's none of the standard navigation controls at the top. For example, picking libraries such as the one that I'm going to describe later gives you a greater choice of language, but it takes you further away from a native experience. And this is not necessarily something you want unless you're writing games. And this is basically because, well, you've written Angry Birds. Your Angry Birds has a completely different art style to native Android buttons. So if you are developing games, and you don't need to have something that looks like a native app, then writing in a cross-platform toolkit like Kivy probably makes sense. So the last piece of the puzzle is native. And when we talk about native apps, we mean apps that are designed specifically with one platform in mind. And indeed, this is all about hooking into the design language of a platform, into the things that make apps behave nicely with each other. And if you do write something with a native toolkit for Android, you get things like structured navigation that behaves the same as every other app on the platform. Having access to things like the sharing API so that you can hook into other apps that can receive data from your own app. These are features that users like because it makes your app feel like it's part of the system they're already familiar with, and they're super easy to code because they're provided as simple APIs. Because, you know, Google want you to use things that make Android interesting and make your app fit in well on the system. So the problem is that both Android and iOS have chosen obscure platforms to base their SDKs on. iOS, you use Objective-C, and that had been the language for Mac development well before iOS came along. And in Android, well, it uses Java, but not quite Java. It uses this weird Dalvik thing, so nothing that targets Java actually works on it. And these are both a problem. It also means that there's really not any native API for either platform for languages other than the official one. In fact, Apple banned anything other than Objective-C and JavaScript for a very long time, sort of to get Adobe to stop releasing Flash compilers for iOS. Likewise, on Android, you can only really code in things that target JVM bytecode. And this means that the communities that are developing for Android and iOS were self-selected. Mac developers came to iOS. Java developers came to Android. This is basically because they already knew the language and knew how to do things. What should be of more concern to us is that as the platforms grew, people who wanted to code Android apps came to learn Java, because that's the only way to produce a native app. So while we know that Python is a great language for developing in, users will prefer Android apps that are written in Java. This is not because of the language that it's written in, but because it is native and Java apps on Android fit in with the rest of the system. So, to recap, 3 ways of developing mobile web apps, or mobile apps rather. There are mobile web apps, which is about as solved as it will ever be for Python, but requires extra care to actually fit in with the platform. There are cross-platform toolkits, but they don't give you a native UI. And people tend to prefer native apps because they fit in with the system in general, but you find yourself stuck using, in the case of Android, Java. So the last section of this talk is to look at where Python fits into Android. What is out there already, and what can we do to improve things? And I'm not going to cover basically any code in this section except until the very end of it, but I'm going to show you what is out there, what you can go and find, what you can do already. So the first thing I want to look at is this thing called Python for Android. This is a project that is working on making Android distributions that include Python interpreters and such like that. So what you get is a way of bundling up Android packages that contain a Python interpreter along with all of the dependency libraries that you need to make your app work. It also gives you a small API that helps you bootstrap an Android app that embeds a Python interpreter. What it doesn't provide is anything that resembles a UI API at all. So what you get from Python for Android, and it's a really good engineering effort, and everything that is running Python on Android is basically using this infrastructure. It means it's possible to get Python code running on your Android device as an app, so something that people can get from the Play Store and install on their device, and that's really cool. So basically the best semi-native toolkit out there for Python is Kivy. It's touch-centric, so it's designed for multi-touch interfaces in mind. It runs on basically anything, and it is written by Python programmers. So the programming interface for it feels good for people who are writing Python. Kivy are also responsible for the engineering effort that's produced Python on Android. So they're also, as well as producing a nice UI toolkit, they're doing most of the heavy lifting for getting other libraries onto Android. So you get a design language to produce UIs in Kivy, but you'll notice that most of the widgets that Kivy provides are completely custom. So you get something that completely does not look or feel like an Android app if you're using Kivy. If you do have a custom style, you're producing a game or something relatively freeform in terms of user interface, then using Kivy might be okay. This is an interactive menu app that Kivy have in their gallery. So it's a restaurant menu that you can interact with. You press a bottle of wine, it gives you some information about it. The styling is completely custom. Nothing resembles native widgets. So using a cross-platform toolkit in this case, it's a decent idea. Likewise, games work well with Kivy. There's only one standard button that's here. People aren't going to care if that looks like an Android button. And I know that there are quite a few games out there on the Play Store that have been written using Kivy. So it's the only mobile toolkit that's designed with Python in mind, and it's definitely worth looking at if you care about that. From what I understand, they're a bit hostile to the outside contributions. Most of the core development is paid through crowdfunding or bounties to pay off the actual core team to develop features. And there's also no actual commercial support for the library. If you do care about commercial support, probably the best other option that you have is Qt. It's a bit rough on Android at the moment. It's been around for ages though, and because Nokia wanted it to be the official toolkit for Mimo, lots of work went into making touch interfaces with Qt. But it's not terribly good on Android in terms of packaging just yet. So what then about making native apps in Python? Well, at the moment, you don't really have any choice other than to code in Java. You can also use any number of languages that compile to Java code or to JVM bytecode. So I know Scala might be one of those, Groovy, things like that, as long as they're compiled on the development environment. And now, Jacob said earlier that he learnt Python because of Jython. And this would be a really good opportunity for Android, wouldn't it? Unfortunately, Jython, it does not work. And I guess I should explain why. So you remember back earlier, you want to write a Java app in Android, you need to convert your JVM bytecode to Dalvik bytecode on the development environment. So with Jython, you write your code and you execute it in the Jython interpreter. This probably works, I guess, but the problem is that if you import a library, the Jython interpreter actually compiles your Python code down into JVM bytecode and then gets executed. And all this bytecode generation happens on the target device, which means that you can't convert your code to Dalvik executables, which means that you can get something that could probably execute a script but won't do anything terribly useful. I would also suggest that Jython is the least actively maintained Python interpreter that's out there. There's been a couple of attempts to make it work on Android, but they've all been abandoned. Last commits 2 years ago. Not a terribly good sign. They've also only just produced a beta of 2.7. That's like 3 years behind CPython, and there doesn't seem to be any sign of development for Python 3 for Jython. So I would suggest that any effort to make Jython run on Android at the moment is locking people into Python 2, and I don't think that's something that we as a community should be supporting. So that leaves the matter of CPython. So we know that with Python on Android, we can get CPython running within Android apps, and indeed running like normal apps. So can we get CPython to get at the Java API for Android? So Python has a C API, and you can use the Python C API to call out to other C libraries. Likewise, you can use the Python C extensions library to embed a Python interpreter inside a C library on your system. So this means that being able to call out to C libraries means that you can basically get to any other piece of software on your computer ever. So meanwhile, Java has pretty much exactly the same thing. The Java native interface, it lets you get back into C code from within Java. And happily, this is one of the things that Android actually kept from the Java infrastructure. The JNI has been taken completely. So if you want to write an Android app that calls out to native C code, you can do that. So basically, you have a way of embedding Python inside a C library, and Java can call out to C code. Then all you really need is some magic piece of software that will let you bridge the two interfaces. And the Kivy project has fixed this again. They've had a project out for the last year called PyGenius. It's a bridge that lets you use the JNI from within CPython. This means that you can call into Java methods from within your Python code. So this is hello world. Basically, all you do is you say to PyGenius, I would like you to give me a Python class that implements the API of this Java class, and then you can call into it. And it does all of the bridging between Python and Java for you. This is a relatively simple example. To give you an idea of something more complex, this is using the Java stack library. It's putting Python strings into a Java stack and then getting them back out of that Java stack again. So you can take Python objects, you can put it inside Java objects, and have that bridging done for you. And finally, you can override Java interfaces. So on Android, this means that you can perhaps write UI listeners for UI objects. All you need to do is derive from Python Java class and use this Java method decorator on top of any method that overrides or implements a Java interface method. So this looks really good, and it's going to probably be the best hope for getting a useful Android API into Python. It lets you get at a very, very large proportion of the Android API, but it doesn't get you everywhere. You notice I mentioned earlier you can implement Java interfaces. Unfortunately, you can't yet override Java classes. If you write a useful Android app, you need to override a whole bunch of Java classes to be able to do that. And this means you can't actually fill out the entire structure of an Android app using PyGenius. Also, the way of overriding methods, you have these awful JNI signatures when you override a Java method. These are hard to use even if you're writing the JNI, and if you're writing JNI code yourself. As a Python developer, I don't know what the hell that means. So we really want to have an API for making these method signatures slightly easier. And then the API is very idiomatic Java. It's very verbose if you're used to writing Python code. So given that there are some problems, what can we do here to fix them? Well, the most important thing that is going to prevent us from writing a working native app in Android is not being able to access the entirety of the SDK. And the solution to this immediately is basically doing code generation. This adds a build phase to your Python program, which you might think is a ridiculous idea, but you have to deploy your apps from your development environment to your target device in order to run them. So adding a build phase that does some code generation is not necessarily going to be particularly arduous. All the code that currently needs to be written in Java to make something that works with PyGenius could probably be generated, and you could add some bridging classes that make that easily accessible from within Python. If you want some ideas on that, come speak to me after the talk. I'm very interested in pursuing this particular avenue. So, app development in Python on Android. As you can see from this slide, basically all of the useful stuff that's being done there is being done by Kivy. But if you're looking to make a native app, stay as far away from it as you can. PyGenius is going to be something particularly useful in the future, I think. So, that basically brings us to the end of the talk. As Python programmers, we would very much like to be able to make great Android apps, but in Python. But unfortunately, we're not really at the point where we can do that. There are some cross-platform libraries that get us part of the way there. If you want to make a fully functional app, you can use Kivy, make something with a touch interface but doesn't feel native. But there is good work that is being done in getting Python ready to be a first-class language for Android. And it's important work because this means that people who want to come to Android app development can choose Python as a language. So let's return to the question that I asked when I opened this talk. Why does everyone in this room use Python? Well, you know, there's this whole heap of reasons that people use Python that you all told me on Twitter. But I don't think that these are the answer. I think that the simplest answer is that people use Python because it solves actual development problems that people have. So some of us have been doing web development in Python for a very, very long time. But I don't think there was really a critical mass for web development in Python until Django came along. I've been writing things that call out to web APIs forever. But it wasn't a task that I particularly enjoy until requests came along. So at its core, Python is a really great language because we have great libraries that solve problems that people actually have. As far as Android dev is concerned, Python's not really a first-class option, so people code in Java. But before you go hating on Java, just remember that Android devs are using Java for the same reason that we currently use Python, because it lets them solve the development problems that they actually have. At the moment, Python on Android doesn't yet. So we know that Python is a great language and that all developers on all platforms should be able to use it. And I think that Python is in a really great position to be a better language for Android development than Java could ever be, because you can write things so much quicker than you can on Java. But before Python can be a great language for Android, Python needs to be a language for Android. So if you take nothing from this talk, go and hack on PyGenius. Make it easy for Python people to pick up. Make it feel like people are coding Python and not some interface to Java. Once Android is a good place for Python people to be, then we can probably go and make Python a great place for Android people to be. And that is the end of the talk. Thank you very much for listening.
Thank you for your talk, Christopher.
We've got 5 minutes for questions.
We have about 5 minutes left, so if you'd like to ask a question, there is a mic over there, mic stand over there. We can line up and ask Christopher a question.
I have this great sense of foreboding.
No, it's okay. So out of the same mouth, you said that Jython doesn't work on Android, and now we have a Python interpreter that's running on Android. What Python interpreter is running on Android that makes Genius work? CPython. You said that you can only develop under Java for Android.
Right, so it is an ARM-based system, and there is a native development toolkit. When I say native development toolkit for Android, it's actually producing compiled ARM executables. CPython compiles to ARM, so you can deploy CPython onto Android. And Python on Android is basically using JNI calls to boot up a CPython interpreter from within a Dalvik VM.
So then how many of the top-line apps that run on Android are written in Java, and how many of them are written slightly in Java and mostly in native C?
It's mostly written in Java because mobile apps tend to mostly be user interface driven. There's generally not much hard processing going on, except maybe in games if you want to do physics simulations and stuff like that. But all of the UI and networking and all the APIs that make Android a usable development environment are all provided with a Java API.
So if I woke up tomorrow morning and decided, all right, now I'm going to become an Android developer, I'm going to write apps for Android, and I'm going to use Python, the first thing I would do would download the 6 million jillion megabyte Eclipse distribution and polish up my rusty Java skills, because of course, to learn a new API, you have to do it the way it's intended to be used before you can do it in some other weird language. And then by the time I've spent a couple months and become a sufficiently Android expert to try it in Python, well, I'll have my head deep into Java and Eclipse and all that. And why would I bother with all that Python stuff? And then there's another developer lost.
So that's where we are with Python and Android at the moment. There is not, Python is not a first-class language in Android, and that's where we need to be. We want to be at a point where if you want to decide to code for Android, Python is a language that you can choose from the start, and it's not there yet.
Okay, so that's the problem.
Yeah, that is the problem that needs to be solved. We are so far behind Java as Python. It's quite sad.
Does anybody at Google even care?
Sorry?
Does anybody at Google even care?
I'm sure there are people at Google who care, but I don't think they're in the right position to solve anything. Not that I know anything, I do not work there.
Hi. A lot of my favorite Python tools are wrappers on shared libraries or native code, and I'm thinking of SciPy and NumPy here. What's the state of the world for getting Python calling native code on Android?
If your code, so if your libraries that contain native code, like your Python libraries that contain native code, compile on ARM, it will probably deploy to Android. There is GCC and Clang available for Android through the native development kit for Android. And you could probably use Python on Android to at least bootstrap an app that calls into these things. But I don't know specifically about SciPy or NumPy. But if it will compile to ARM, there's a good chance it will run on Android.
Okay, yeah, I've used the native development kit, but it sounds like I'm on my own there.
So I've used JPipe a little bit, which is another JNI library for Python on the desktop. And
Yeah,
I found
sure.
that to be a pretty upsetting experience, that it didn't work a lot of the time and there were a lot of problems, especially when I was dealing with threads.
Right.
And I was wondering what your experience has been like with PyGenius.
Okay, I haven't used Genius all that much, but it's what Kivy is using to make most of their stuff work. Every time they need to call out to the Android SDK to do something, that's what they use. And they started it because they had pain points with JPython. And the API for it is considerably easier than JPython. It's a bit rough at the moment. It really does need to be improved.
Okay.
But it looks like a really good hope for getting Java code running from within Python. Is that it?
Yes, that's it. It's 11:35. It's time for a coffee break. Can everybody just thank Chris again?
Hey, thank you.